Okay guys, today we're going to be continuing on talking about key features of graphs, but we're going to learn about two additional key features. Key features of graphs, day 2. Before we get there, I want you to review from yesterday and try out the warm-up problem about the roller coaster. Notice how we're using those same vocabulary words as yesterday, so have those notes handy from yesterday if you need to. The maximum point of the roller coaster, we're going to talk just today about the absolute max for this roller coaster, and you should have found that that was at 250, 110. The next part of the graph that you needed to look at was where the roller coaster was going uphill. In other words, the area where it's increasing. Let's check that out. You should have had this portion and this portion. Remember, we write those as inequalities in terms of x. So you should set up two inequalities to describe those areas where the graph is going up. That first one occurs in between the x values of 0 and 250, so in the first 250 feet of the track. And the second portion occurs, looks like, in between 550 and 800. Hopefully you're able to figure out the graph is counting by 50s. The minimum occurs in two different locations, over here and over here. There are two minimums, so we'll say at 0, 10, where the right is starting, and at 1250, 10. The last one, the point where the roller coaster begins, is the y-intercept. You should have gotten that y-intercept was 0, 10. So in other words, it starts 10 feet off the ground. Go ahead and have some highlighters handy as we work through our work today. We're going to be talking about positive and negative areas of the graph, and we're also going to be talking about end behavior of a function. All right, so positive and negative is what it sounds like. The positive part of the graph is, we're going to fill this over to the right over here, left, where the graph is above the x-axis. So the positive portion of the graph is where it is above the x-axis. Let's fill it in the blanks as well. The positive region of a function are the intervals where the function is above the x-axis. It is where the y values are positive. Not where they're equal to 0. So take a highlighter out, either on your computer or on paper, and highlight this portion of the graph. This is where the graph is positive. Conversely, or on the other hand, the graph is negative when it is below the x-axis. So the negative regions of a function are the intervals where the function is below the x-axis. It's where the y values are negative. So I'm going to take out a different highlighter color and highlight this portion of the graph to show this is the region of the graph where it is negative. You know, when we were talking about intervals of increase and decrease, where the graph is going up and where the graph is going down, how we wrote it in terms of x, you'll write the positive and negative portions of the graph in terms of x as well. So you'll still have your inequalities. You put your small x on the left and your large x on the right to describe where it's either positive or negative. And we're going to take a look at that in those examples down below. Again, because so much of this stuff is visual, I would highly encourage you to use highlighters. Maybe if you're using it on paper or via Cami, highlight the portion of the graph where the graph is negative. Remember that that is the region that is below the x-axis. You'll notice that we have two regions where the graph is negative. And I'm just going to go ahead and do a big ol' assume here and assume that we have arrows on both ends of this graph. Since we have two regions where the graph is below the x-axis, we're going to set up two inequalities. We'll do that in terms of x. So let's look at this left portion over here. On the left, in terms of x, these x values are going forever to the left. So we'd say from negative infinity up until this x value of -4, the graph is negative. In other words, the graph is below the x-axis. The next portion of the graph where it's below the x-axis is this portion right here that I've highlighted in yellow. That is between the x value of -1 to +1. Let's try it out for the positive region of the graph in the example number 2. Positive means above the x-axis. So the only portion that we can see above the x-axis is that portion of the graph that I just highlighted in pink. Let's set up our one inequality since we only have one region. And let's estimate that x value. We'll say it's like at 1.25. It's where it starts becoming positive, and then it ends around 3.9, we'll say. If you came up with different decimals, it's just an estimation. That's okay. Last one, we're going to do positive and negative. So let's use two different colors. I'm going to do positive above the x-axis in pink. You should have three regions there. And again, let's assume these are arrows on the end. And then I'm going to do negative in green. So this region's negative because it's below the x-axis in this region. So if we're talking about the positive region, since we have three different regions of the graph where it is positive, we're going to have three different inequalities. The first portion of the graph has an arrow on the end. It's going up, but it's also going to the left. So in terms of x, since it's going to the left, we say that is negative infinity. If you're thinking positive infinity, you're thinking in terms of y. So make sure you're thinking in terms of x here. It's going forever to the left. All these x values to the left are getting smaller and smaller, so that's negative infinity up until it changes from positive to negative at that -1 value. The next portion, where it is positive, is this little hump in the middle from 1 to 2. And the last portion starts at 1, 2, 3, and continues up, but that's in terms of y, so think about it to the right. It continues to the right forever and ever, so we say that that is infinity. Go ahead and pause the screen and you try to write the negative portions of the graph. Write them as inequalities in terms of x. You should have this portion of the graph that's negative begins at -1, and you continue to be negative until the x value of +1. The next portion of the graph becomes negative at the x value of 2 and continues to 3. Go ahead and rewatch anything about positive and negative that might have confused you there. Key ideas: positive above the x-axis, negative below the x-axis, and it's all written in terms of x. The very last key feature that we're going to take a look at is called end behavior. End behavior is what happens, you're answering, what happens to the y values as x either approaches positive infinity or negative infinity. Now, on your axis, you'll notice that your x and your y, on your graph, you'll notice that your x and your y are labeled. I just want to remind you how we describe positive and negative infinity. So if things are continuing forever to the right, we call that positive infinity. Similarly, If things are continuing forever up in terms of y, we also call that positive infinity. If the graph is continuing forever to the left, those x values are getting smaller and smaller, we call that negative infinity. If y values are going forever down, we call that negative infinity. So up is positive infinity, right is positive infinity, left is negative infinity, and down is negative infinity. You write your end behavior as a sentence, as a math sentence. So first of all, I want you to take these examples below and assume that there are arrows on the ends of all the graphs. You can only talk about end behavior if there are arrows. So these graphs are not perfect in that regard. Should have put arrows on the document, but go ahead and add arrows to each of those graphs. If there are no arrows, you cannot talk about end behavior. So you only can talk about end behavior if you have arrows on the end of the graph. When you're describing end behavior, you'll write your math sentence like that one that's scaffolded down below there. We will state, as x goes toward negative infinity for the first sentence, and as x goes toward positive infinity for the second sentence. So if we are answering this first sentence for end behavior, this is saying as x's get smaller and smaller. So as x's get smaller and smaller on this graph, as we go to the left, what is happening to our y values? You'll notice that they are going up and up and up. We would say that the y values, which is the same as f of x, are going up, which means they are approaching positive infinity. So as x approaches negative infinity, f of x approaches positive infinity. That's just saying as x gets smaller, y gets larger. But we write it with this math notation. Let's look at the second sentence. As x approaches positive infinity, so as x gets bigger and bigger, as the x values go to the right, what is happening to our y values? Our y values are going up again, so f of x, which is the same as y, approaches, that arrow, approaches positive infinity again. Let's try it again with the example to the right. As x approaches negative infinity is going to be our first one, and as x approaches positive infinity is going to be our second one. So in our first sentence, as x gets smaller and smaller, so as the graph goes toward the left, what is happening to our y values? Our y values are decreasing. They're going toward negative infinity. So we would say that f of x, arrow, or approaches negative infinity. On the other hand, for our second sentence, for the right end behavior, as x gets larger and larger, that's the right side of the graph. As the x values get larger and larger, where are our y values going now? They're continuing to go down. So we would say f of x, same as y, approaches negative infinity. In these bottom two examples, we are going to practice writing the entire sentence on our own. Remember that you can only do end behavior if you have arrows on the end of your graph. If there was a dot, a solid dot at the end of these, we cannot talk about end behavior because it's stopping. It's not approaching positive or negative infinity. So let's start off with our first math sentence talking about the left side of the graph. We would say as x approaches negative infinity, comma, f of x approaches, and now we have to fill in the blank. So look on the left side of the graph. As x gets smaller and smaller, where are our y values going? You'll see that that arrow is pointing up. Up is the same thing as positive infinity. Now, let's look at the right side of the graph. As x approaches positive infinity, f of x approaches, and now we have to fill in the blank. So on the right side of the graph, as x gets bigger and bigger, what is happening to our y values? They're getting bigger and bigger again, so we would say it's approaching positive infinity. Pause the screen and try out the last example on your own, making sure that you write this entire math sentence. You should start out looking at the left side, which is when x is approaching negative infinity. So as the x values get smaller and smaller, look at what's happening to the y values. F of x is going down, which is toward negative infinity. So as x gets smaller, y gets smaller. Another way of saying that, as x approaches negative infinity, f of x approaches negative infinity. Now let's look at the right side. As x approaches positive infinity, f of x approaches, well, as x gets larger and larger, what's happening to our y values? They're getting smaller and smaller, so we would say they go toward negative infinity. Rewatch anything about end behavior that might have confused you? Yes, you always have to write this complete sentence, both of them, the left side of the graph and the right side of the graph, assuming there are arrows on both ends. Give your homework a shot. Ask questions if you got them.